This is our 2.6, 2.7 practice homework. This is the first part. God bless you. The graphing part is going to be something we go over tomorrow, and then I'll answer any last minute questions. But here, the first part is asking you to find the domain, vertical asymptotes, horizontal asymptotes, and x-intercepts. So the first thing I want you to do is tell me how to find each of them. Domain, what do I do? Look at your little cheat sheet. Okay, so we're going to say set denominator not equal to 0, right? Okay, so denominator goes along with what other thing? Vertical asymptote. Okay, your vertical asymptote is a line that is vertical, that the graph will approach but never, never touch. It's where the graph does not exist, where the function doesn't exist. A vertical line is written as what kind of x equals or y equals? X equals. Good. It goes through the x-axis. So it's x equals. And how do we find vertical asymptotes?
You said the demand is 0.
Set denominator, God bless, equal to 0. All right? Horizontal asymptotes are horizontal asymptote. X equals or y equals? Y. Okay, look at our little cheat sheet. There's 3 things we need to know or to compare. We're always going to compare the degree of the numerator to the denominator. Yes?
Yes.
Okay. So when the numerator and the denominator, tell me the first thing you want me to write down. Okay, when the numerator equals the denominator, degree, the highest exponent.
There is no horizontal asymptote.
When they equal each other? Look at your little cheat sheet.
You're supposed to do the leading coefficient.
Okay, you're gonna write the leading coefficient of the numerator over the leading coefficient of the denominator and simplify. Y equals. When the numerator degree is greater than the denominator, what happens? When the numerator exponent is bigger than the denominator exponent. Everybody check. Everybody look at your cheat sheet. Tell me. What does it say? Everybody look. Everybody look. Everybody look. None? So you write none or no horizontal asymptote. Do not write 0. What happens when the numerator degree is less than the denominator degree?
Y equals 0.
You have a horizontal asymptote at y equals 0. That, to me, is probably the thing that you guys are going to mistake the most. You have to practice that. Have to. All right, and then how do we find x-intercepts?
Set x equals 0. Oh, wait, y equals
Look at your cheat sheet, please. Don't just say, what do you think? How do we find x-intercepts? Set the numerator. Good. Set numerator equal to 0. We're going to do that on every single one of these problems. You should be referring back to that little cheat sheet I gave you 100 times. Look back, look back, look back, look back. Make sure you guys know what's going on. So, this first one, whoops. We're going to talk about the domain. How do I figure out what the domain is? Set the denominator not equal to 0. So 3x squared plus 3x minus 18 cannot be 0. Well, guys, this is a factoring problem. What's the first thing you look for in factoring? GCF. What can I take out of all 3 of these? 3. So I'm left with x squared plus x minus 6 cannot be 0, correct? All right, so factor this. What times what gives me a negative 6 when I multiply, but a positive 1 when I add? Okay, plus 3, minus 2. I know you said that. I just want to make sure everybody was with me. I got you. So now how do I solve this? A lot of people ask me questions. What do I do with the 3? Guys, you said each piece equal to 0 or not equal to 0. This is nothing. So x cannot be what 2 numbers? Negative 3 or positive 2. That's your domain. When I solve or I figure out my domain, what did I also figure out? Your vertical asymptote, right? Your vertical asymptote goes along with set the denominator equal to 0. So I have two vertical asymptotes. Where?
At
At
x equals.
x equals -3, and at x equals what? +2. So if I were to graph that, I would have a vertical line over here at x equals -3, a dashed line, and I'd have one over here at 2. Does that make sense? All right, what's the next thing I have to find? Horizontal asymptotes. How do I find a horizontal asymptote, guys?
You look at the degree.
You look at the degree of the numerator and degree of the denominator. Some people had some questions about this. How many x's do you see here in this numerator?
None.
There's none, so it's x to the 0 power. Good. So if I compare, what is the degree of the numerator? 0. What's the degree of the denominator? 2. What is the relationship between 0 and 2? 0 is less than 2. So if I go up here, what happens when the numerator degree is less than the denominator degree? Perfect. So you have a horizontal asymptote at y equals 0. Very good. And then the last thing is my x-intercepts. What's the rule for x-intercepts? Set the numerator equal to 0. Okay, watch, guys. 1 equals 0. Is that ever true? So what does that tell you about your x-intercepts? Correct. There are none. That does not mean 0. X equals 0 is a place on a graph. There are no x-intercepts here. Questions? We okay? Okay, good. Good. All right, let's look at number 2. Let's go through the list again. Domain. How do I find the domain? Denominator not equal to 0. I'm going to go through these and say the same thing every single time so this gets in your brain. If I said the denominator not equal to 0, I know my domain is all real numbers except what? X equals 4. You can tell me x cannot be 4. Everything in the world will work except for 4, because what happens when I put 4 into this equation? The denominator becomes 0. Good. So since I already found my domain, I, in a sense, already found my vertical asymptote. Where the denominator becomes 0, the function does not exist. That's where our vertical asymptote is. So I have a vertical asymptote at x equals. Good. Let's find our horizontal asymptote. What's the degree of the numerator? 1. What's the degree of the denominator? What is the relationship there? They equal each other. So when I have equaling degrees in the numerator and the denominator, how do I find my horizontal asymptote? Leading coefficient of the numerator over leading coefficient of the denominator. So where is my horizontal asymptote at? Y equals 1. So think about this. If I was going to graph this, I'd have a vertical asymptote over here at 4. And then I would have a horizontal asymptote here. So my boomerangs, if I were to graph, would be here and here. We'll do more of that tomorrow. Yes, ma'am.
Are the numbers like precise, or are they just like a general idea?
Just precise. I mean, general. You want to get really close to the asymptotes, but not touch. Okay, and then the last thing we need to find is our x-intercepts. How do I find x-intercepts? Set the numerator to 0. So where is the x-intercept? At x equals what? 2.
Can you go back to number 1 for a quick second?
I mean, when I find that my x-intercept is 2, one of my boomerangs should go through what number? Yeah. You just have to use the intercepts to go. Okay, again, 3. Okay, this looks a little hairy. No worries. First thing I'm going to find is domain. How do I find the domain? Denominator equal to 0. Good. So I have negative 3x squared minus 3x plus 18 equals 0. GCF. Negative 3. I'm glad you said that. Negative 3. So all of my signs are going to change. This becomes x squared plus x minus 18. Just kidding. Minus 6 equals 0. So I have negative 3. Factor this. Factors of negative 6. That give me a positive 1 when I add. X minus and x plus. What? I want a positive 1 when I add. 3 and 2 I agree with, but what are the signs? Negative 2 and a positive 3. So again, negative 3 cannot equal 0. We're good. So I have x equals what? X cannot be 2 and x cannot be? Good. So since I found my domain, I also found what else? Vertical asymptotes. I have 2 vertical asymptotes where? At x equals negative 3 and x equals 2. So if I were to graph it, I'd have my dashed line vertically through negative 3 and over here at positive 2. Now I have to look for my horizontal asymptotes. Well, how do I do that? Compare the degree of the numerator and denominator. So my numerator degree is 3. My denominator degree is 2. It's the highest exponent. What is the relationship between 3 and 2? 3 is greater than 2. So go up here. What happens when the numerator degree is greater than the denominator? There's none. There's no horizontal asymptotes. You either say none or no horizontal asymptote. Don't put 0. And then, my friends, how do we figure out the x-intercepts? Say it nice and loud. Numerator equal to 0. So x cubed minus x squared minus 6x equals 0. What do I take out? Good. Very good. So I'm left with x squared minus x minus 6 equals 0. What does this factor into? I want a negative 1 when I add. Negative 3, positive 2. So now I set each piece equal to 0. So I have x equals 0. I have x minus 3 equals 0. And I have x plus 2 equals 0. So where are my x-intercepts?
X equals 0.
At x equals 0.
X equals 3.
X equals 3.
X minus 2.
And x equals negative 2. It's just getting easier. It's just repetition, guys. You need to know where to look and what you're looking for. Let's go over to 4. Excuse me? Excuse me? I wasn't going to. I'm just kind of going through just like visuals on that. We're going to go through all the graphing tomorrow. I want to make sure we get this in our brains. All right, let's look at 4. Tell me everything. What are we doing? Domain. Okay, x squared plus, just kidding. All right, negative, whoa, what's going on here? Negative 4x squared minus 16x minus 12 equals 0. GCF? Negative 4. So I'm left with x squared plus 4x, what? Plus 3 equals 0. Negative 4. What are the factors of positive 3 that when I multiply I get 3 and when I add I get 4? X plus 3, x plus 1. Good. So I have my domain restrictions. What can x not be? Negative 3 and negative 1. Good job, guys. So I also found my vertical asymptote. My vertical asymptotes are at x equals negative 3 and x equals negative 1. Agreed? Yes. Okay. So next we're going to find our horizontal asymptotes. Horizontal asymptote. How do I find my horizontal asymptote? Degrees. So numerator degree is 2, denominator degree is 2. What's the relationship? Equal. So I have leading coefficient of the top over the leading coefficient of the bottom. What is the leading coefficient of the numerator? 1. What is the leading coefficient of the denominator? Negative 4. So my horizontal asymptote is at negative 1/4.
Is it y equals negative 1?
Uh-huh. Horizontal. Think about a horizontal line. It's going to go through what axis?
The y.
Yep. All right. Now let's do our x-intercepts. How do I find x-intercepts?
You set the numerator equals 0.
Numerator equal to 0. So x squared plus x minus 6, right, equals 0. All right, factors, again, of negative 6 that multiply to give me a negative 6, but add to give me positive 1.
3.
Plus 3
And negative
and negative 2. So my x-intercepts are at x equals what? Negative 3 and x equals what? 2. We okay?
Yes.
I'm just starting to get a little redundant.
Yes.
Good. I want it to be like that. Domain. How do I find the domain? Denominator cannot be 0. Guys, factor this.
Oh,
X plus 3 and x what? So x cannot be what two numbers? Can't be negative 3, can't be positive 3. So my vertical asymptotes are at x equals what? 3 and x equals negative 3. We good? Okay. Horizontal asymptote. Look at your degrees of your numerator and denominator. What are they? They're equal. That means I take the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator. So I have a horizontal asymptote at y equals what number?
1.
Good. How do I find my x-intercepts?
So then
Numerator equal to 0. X squared minus 4 equals 0. What is that?
x plus 2,
X plus 2, x minus 2. So I have x-intercepts at x equals
2.
positive 2 and x equals what?
Negative
Yep. Mm-hmm.
Wasn't it x squared minus 9?
For what?
Right.
X-intercepts its numerator. That's okay. Don't apologize. That's okay. Okay, let's look at 6. Domain. How do we find the domain? Set the denominator not equal to 0. Good. I'm so glad you guys are like, "Boo, boo, 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 boo." I don't care. You get it. That's all that matters. Factors of negative 12 that multiply to give me negative 12, but add to give me a negative 1. X minus 4, x plus 3. So x cannot be what two numbers? What happens when x is 4 and negative 3? The denominator becomes what? What happens if I plug in 4, if I plug in negative 3?
Real number.
What happens? The 0. We can't have the 0. So what happens at that point on a graph when the denominator is 0? What occurs?
It,
What
oh,
occurs?
there it is. What it's called.
It's right there. Vertical asymptote. So your vertical asymptotes would be at x is 4 and x equals negative 3. If you're if you were to graph that, it'd be over here at 4 and then here at negative 3, right? So now let's find our horizontal asymptotes. What do I do for a horizontal asymptote? Okay, so 2 equals 2, yes? So what does that mean? Leading coefficient of the numerator over. Do you guys agree with me when I get y equals 2?
Yes.
Okay,
No,
so
wait, are we number 6? Aren't they just equal?
yeah. So what's the leading coefficient of?
Oh, yeah.
Okay. That's okay. No worries. All right. Let's look at our x-intercepts. How do I find x-intercepts? Numerator equal to 0. Good. 2x squared minus 12x plus 16. What do I do first? Factor. What do I take out? 2. Good. So I'm left with x squared minus 6x plus 8. Good. We got some different numbers here. What times what gives me a positive 8 when I multiply, but a negative 6 when I add? It's either 8 and 1 or 4 and 2.
14.
There we go. What kind of 4, what kind of 2? Negative. So set each piece equal to 0. Will 2 ever be 0? No, so that doesn't matter. X minus 4 equals 0. X minus 2 equals 0. So what am I at?
X equals 4.
I have intercepts at x equals 4 and x equals 2. Good. Good.
This is so much easier
It is.
than expected.
Okay, here we go. Domain.
So,
Good. Negative 3x minus 6 cannot be 0. So what do I take out of both? What kind of 3? Negative 3. Always take out a negative if it leads with a negative. So I'm left with x what?
X plus 6 plus 2. I'm sorry.
It's okay. No one's mad at you. It's
I'm mad at
fine.
myself.
It's okay. Look, negative 3 cannot be 0. You're fine. So x cannot be what number? Negative 2. Good. So my vertical asymptote occurs then where? At x equals negative 2. Do you guys notice this is not equals, this is equals. Make sure you're on top of that. My horizontal asymptotes. How do I find my horizontal asymptotes? Look at your degrees. What's the degree of the numerator? 2. What's the degree of the denominator? 1. What's the relationship there? 2 is greater than 1. So the numerator is greater than the denominator. We haven't had one of those in a minute, so let's look and see what happens. When the numerator is greater than the denominator, what do we write? None or no horizontal asymptotes. Yes? Good job. This is much better. Now, x-intercepts. How do I find x-intercepts? Numerator equal to 0. So x squared plus 2x minus 3 equals 0. Factors of negative 3 that multiply to give me negative 3 but add to give me 2. X plus 3.
And then X minus 1.
X minus 1. So x-intercepts are at x equals negative 3 and positive 1. That means the graph will cross the x-axis how many times? Where?
X minus.
Good. Good. Okay, good. That makes me feel a lot better, guys. All right. Long division. Slant asymptote. What do we have to use? Long division. Those of you who are like, I don't like long division. Get over it. It's not that bad. Ooh, I like that. I love long division.
I like it.
All right, there's a couple things we got to pay attention to when we do these, so let's make sure. First of all, slant asymptote, all they're looking for is the mx plus b. Remainder doesn't what? Doesn't matter. Don't worry about it. You can even stop. If you don't want to, that's fine, but I'm just letting you know. So I have x plus 5 on the outside, yes? And then x squared minus 6x plus 7. Make sure you check you don't have any gaps. Do I go x squared, then x, then no x? Yes. Okay, so we're good. So I say first term into first term. X times what gives me x squared? Put it above. You guys see how you have a negative 6x? If you're going to put in it, look, keep in line columns, however you want to look at it, you want to keep your exponents. That'll prove to be helpful in a second. So x times x is x squared. X times 5 is plus 5x. Let me move this x over a little bit so you guys see it. So before I subtract, what do I have to do? Distribute, distribute, distribute. So I have negative 11x, correct? My x squareds cancel, and then what do I do with the 7? Plus 7. And now we do it all over again. X into negative 11x. Negative 11, good.
You stop.
You can just stop right there if you want to. If you want to just, for looks, go like this. Negative 11 times x is negative 11x. And then you have, what, negative 55?
Yeah.
If you want to do that, that's fine. And then change, just to make sure these cancel out, but you're good. So your answer for your slant asymptote, it would be slant asymptote at x minus 11. So when I say to you that they want it in mx plus b form, you could graph this. What's the slope? What's the number in front of x?
11.
The number in front of x. 1. So the slope is 1, and where does it cross the y-axis?
Sorry.
Negative 11.
I forgot what slope was.
It's okay, honey. It's fine. All right, here's a tricky one. I want you guys to pay attention. What goes on the outside? What's our divisor?
The big one.
The big one. Okay, we'll say that. X squared plus 3x minus 1. What goes on the inside?
Small.
The small one. Guys, it goes 5x cubed. Is there an x squared? No. So then you have to put a 0 and account for it. Is there an x? No, so you have to put a 0 and account for it. Then we have our negative 8. Sky and I did this one this morning, and she did it perfectly. I was really impressed. Here's a thing to make yourself remember what you're doing, to keep yourself in line. I'm going to go x squared into x cubed. Roll. All right, so x squared times what gives me 5x cubed? Okay, guys, watch. 5x. Where should I put 5x?
Above the 0.
Above the 0x. Look, this will keep you organized because now you're going to see, oh, I'm going to multiply and I'm going to get 3 terms here. If you put it above the x squared to the x cubed, you're going to get yourself confused. So now let's multiply. What's 5x times x squared? 5x cubed. What's 5x times 3x? 15x. And then what's 5x times negative 1?
Negative 5x.
Good. Before I subtract, what do I have to do? Okay, so I have, this should be x squared. Juan just pointed out. Thank you. So now, before I subtract, I distribute, 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 distribute. So what's 0x plus 5x? 5x, good. What is 0x squared minus 15x squared? Negative 15x squared. And then I bring down the 8. So now we do the same thing. What is x squared into negative 15x squared? Negative 15. What can I do right now? I can stop, but I'm not going to. I'm not a quitter. Negative 15x squared, then what's negative 15 times 3? Negative 45x. And then negative 15 and negative 1 plus 15. And then if I go through and distribute, I have a remainder, yes?
Yes.
So don't worry about it. What is my slant asymptote?
Do you have to simplify it?
It's 5x minus 15.
5x minus 15. Now you can leave it.
So this will be 5 and then the y.
Intercept would be?
Negative
Perfect. Good, Emmy. All right, the last one. This is kind of gnarly, so we're going to change it. Let's just change it to x minus 6. So when I see slant asymptote, I think my favorite thing to do is long division. Good. So I have x minus 6 outside, and then I have x squared plus 6x minus 4 on the inside. Check to see if you have gaps. X squared, then x, then nothing. We're good? Okay. So here we go. X into x squared is x. So x times x is x squared. X times negative 6 is negative 6x. Guys, this does not just cancel out. Before you subtract, what do you have to do? Distribute, distribute, distribute. So 6x and 6x is 12x. X squareds cancel out. Now I bring down what? The negative 4. And what do we do? All over again. X into 12x. Well, x times what gives me 12x? 12 plus 12. What can I do right now? What can I do? I can stop. But I'm not going to. I'm going to say 12 times x is 12x. And then 12 times negative 6 is negative 72. And then before I subtract, I distribute, distribute, distribute. Did my x's cancel out? I'm good. So I have negative 78 here. Doesn't matter. What is my slant asymptote at? No. Why? Because right here we distributed the negative. So it was 6 and 6 is positive 12. So then x into 12x is just 12. No. The slant asymptote? No. Your slant asymptote is at x plus 12. Remember, it's always going to be mx plus b. It's going to look like a line. How do we feel now after going through this, looking at our cheat sheet 1,263 times? Good, 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 good. All right, I will upload this, and then tomorrow I'll go over any questions that you have additionally over your quiz. Like if you look at it, you're like, oh, shoot, I should have done this. Oh, somebody go get Jaden.
Where's he at?
I don't know. I forgot that. I sent him outside. Oh,